almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.
Hey everyone, how are we doing? A little bit of office hours in the afternoon. Had some meetings this morning. So let's take a look. What do people want to cover? It is your call right now. Tell me what to cover and we'll start talking about it. What questions are there? Which questions do you have? Let's see. What things do people want to cover? Untransform the log 10. So to untransform a log 10, and we're just going for, let's go here. Untransforming a log. So BAS 320. So here we are at the 205 BAS 320. Untransform form a log 10. Now, has your Y and your X been log 10? Your Y and your X been log 10. So if you have a log 10 transformation, let's think about this. Here we go. Let's write a little equation. Say log 10 height. Log 10 height equals 8 plus. Was probably the person likes to watch football, given she also likes to watch. Which one is that, Meredith? Which one? Let me know which one that is, Meredith. That's 201, right? That's a quiz question, right? We can do that here. Also, what if the intercept given the homework PDF is not the same as the one I get on our studio? Let me know. That might be an issue. Your model might be reversed. You might send me the code and I can double check, and then let me know if the grader doesn't count it properly. Yeah. You might. Yeah. For that one, Meredith, you want to do the table and look at those who like the one and look at only those as a subset. So you're saying untransform log 10, right? So to untransform the log 10, if we have like 2.8 or 2.8 height or weight. So here is it just your Y or your X? So here is a Y. Ooh, good question right there. Taylor, let me grab this. Chapter 12. Drop those questions in 320. Because I got a lot of questions coming up right here. 201 question right here. Landlines from the homeworks. Thank you, 201 right there. Stat 201, chapter 12, homework, landline surveys. Just the Y. Cool. So with just the Y right here, to remove a log 10, you actually have to do what? You actually have to take everything right here and raise it all to the 10th power. So go 10 raised to. And I think if you want to do this with notation, I think you do the following. Let me check. EXP, I got to look at my... There we go. Look at that. So now that raises that, but you have to raise both sides of it. So this is how you write it. Like you can write this out, or you can use the notation here. So if you raise both sides to the 10th power, does that make sense, Meath, right there? Raising both sides to the 10th power will do the same algebraically. So raising both sides to raise like 10 to this, 10 to that is going to keep both sides the same right there. Got it? And then guess what? Like, frankly, it's about as much as I care to do to it. And please tell me if the grader doesn't say you're right. But this right here cancels. So now this cancels. And there you go. Yeah. Nice job, Meredith. Excellent work, Meredith. Let's throw 1,000 points. Does that make sense there, Meath? Let me show the full process of this. If you raise both sides to the 10th power, so if you have your Y has a log 10 on it, raising both sides to the 10th power will remove a log 10 transformation. So do I not have an equals right there? Yeah, no, that's the equals. And this is the LaTeX writing. Does it for the LaTeX, like this is just LaTeX writing right here. You have to put it in the curly brackets for it to recognize it and then do the raise to power. You don't have to write it this way. You could probably just write it out normally, but this will make it should knit to your document like this now, showing the equations written out. So if you do the $, don't do it in an R chunk. And if this is not working for you, I would just write it out normally. But this is, I have 11 minutes. Could you do the question 5 if you want to land? Yeah, I think, is that the one? I think landlines and surveys. Yep. I think that's the one that Taylor wants right there. Thank you, Tara, asking about that too. I think Taylor's asking about that. So we'll do that one here. 320, what other questions do you have? Drop the, so Meet, how are you doing on this? Does that make sense on how to untransform a log 10y? How do we get something out of that right there? So now the y, we'll call this untransform, then we'll do the one next. You got this. We'll say untransforming y's. Okay, so now you have something that is to the negative 3/4 power. Does that make sense right there, Abby? So these are just examples showing how to do it. If you call the $, right here, it puts it in equation format for you. So that calls what we call LaTeX writing right there. So now you have y to the 1/2. Those things keep throwing you off right there. So let's take a look. You ready? The first one right here is the y has been raised to the y has been raised to, so let's take our y and we will say y raised to the negative, and I'm going to write it this way. And we need to remove this because we're not going to have the x transformed on this side. It can be whatever on the other side of the equation. But does that make sense? Y has been raised to the negative 3/4 power. Do you follow with this right here, Abby? Is that similar to what you're doing? Thank you for the Red Cross. Let's add it to the list. Thank you, Caden. American Red Cross. You bet. Chapter 12 quiz. How does that look right there? Does that look similar to the work you're doing? How does that look? Chapter 12 quiz. How does this look right here? Does that look? Yep. Mm-hmm. But the x is also raised. Whatever. No, here, I'll do it right here. The x can be raised to whatever, basically, because that will not be focused on. We won't. So the reason I say
It doesn't matter.
is because we go for just untransforming the y. So if we raise this to the negative 2.25, that one's not the big focal point. And please tell me if you think the grader, like, due to your notation or anything, didn't, like, give you the right grade. So when you think about negatives, what does negative powers do to something? Negative powers does what to equations? Like, what does negative powers do to equations? And actually, there's a really easy way to deal with this. It flips it, right? So how can you undo negative 3/4? How could you reverse a negative 3/4 power? How could you, like, undo negative 3/4? What would be the untransforming of negative 3/4? How could you undo it? So the goal is you get the power back to 1. So how could you undo that? Negative 3/4 could be undone with what? So the question becomes, how do you make negative 3/4 equal to 1? How could we undo that? Like, we just want this to be height. Multiply by the reciprocal, right? So great job right there. So we take right here, and the mathematics for it is going to be to multiply this by, so we should take the power right here, multiply that power by the negative 4/3. Does that make sense? So that should be a minus right there. It's not minus, it's times negative. So we could put this in little parentheses right here. So it is that power times that power right there is going to undo it. And then that means we can't just do it to one side right here. We'd have to go here to this other side of the equation and put this inside here and raise it to the negative 4/3. Oh, I put it in the wrong side. I don't do that much LaTeX. Well, let's put this all in parentheses right here like that. And then this would be raised to the negative 4/3. Does that make sense right there? So both sides are going to be raised to the power negative 4/3 to undo it. So because the negative 3/4 and negative 4/3 are just going to cancel, we're going to get over here on this side of the equation the following, like those just cancel out, should appear below here. You going to appear? You going to be nice? And it doesn't want to be, there it goes. We get this on the other side, and then you could do a little algebra here to make it look nicer. where you flip it and put it to the bottom. So you could, like, the grader should count things like this because that's done. Does that make sense on how to do that right there? Great job, Meath and Olivia right there, and Abby. How are we doing on that? Was there another one people were wondering about? The negative 2.25. It's like, whatever. I mean, everything, all we're going to do is what now? Like, what is the point of solving for y? Because now with everything solved out here, what are we going to do with this? Like, what is the utilization of this that we talked about a lot today? The utilization of this is simply to what? Simply now, what do we do right here when we have this equation, which we could easily do? The utilization of it will be to do what? To simply just what? Just kind of plot it. Submitting number 4. I thought we were just writing the equations. Oh, you're talking about the untransform? And you just plug in x. How are logs listed in the fine transformation? I think it says log 10, log 10. If you make a model, do we have any models stored? We do have a model stored. And if you run the fine transformations on it, and we got figure too large for margins. If there is a log transformation, still too large. And there it is right there. There's the log 10. So the goal of them is to, so Tyler, did that help answer right there for the untransforming? I thought we were just rewriting the equations. And that's what I was doing right here. This makes it so when they knit to your document, they'll actually look like equations. Just let me know if you think the grader. Let me know if you think the grader doesn't count them properly. But this right here is going to be, if there's log 10s, we will see them show up right there. The figure size too large for margins. That occurs when the window over there on the far right is too small. And so if you get that error right there, the plot being too large, make sure this right here, you might need to decrease your view by going to zoom in or zoom out. Probably zoom out. I have no idea how to write logs in R. We can just write log 10 right here. To write the log, if you want to write it, does that make sense, Zoe, for that one? Log 10 written right there, the log 10 of height is equal to 8 plus 2.8. You're welcome, Olivia. Thank you for asking. Just keep asking those questions. That is how to write the log 10 right there if you want, just log 10 height. Now, if you want to do log 10 of something, same as, yes, that would work. That would, so, great job, Meath, right there. You can use log, you can use log of like 10 and then base of 10, or log of 2, base of 10. Log 10 is log 10 right there. It uses only log 10. What is log? That is the way to do it with LaTeX writing. Log, which part are you wondering about, Zoe, right there? This is the LaTeX way of writing it. You don't have to write out this way. It basically does the really fancy, like when you knit it to your document, it'll show it this way. So when you knit these equations, which I think we can do right now, let's see, knit to HTML. This makes it all fancy. Cool and fancy right here. Oh, got an error. Could not find object M. So that's because I've called a model that doesn't exist. And the model was called right there. So it said you have called something that doesn't exist. And as long as they're written out, just that's the first thing I'd focus on, is just writing them out. And don't worry about making them look too pretty. But if you want, do you see how my equations right here are written? So it actually shows the displayed thing right there. So it's showing the equations like that. So it's pretty neat. Yeah, just worry about writing them out first. Making them look pretty can take extra time. Dumb question, but where do I find the questions? The questions should be in the document down here towards the end. There you go. There's the document. There's the untransforming. If you click on these, they will display. And then you see how it has the answer right here. This is going to display, and you can just type whatever you want, and then it'll display your answer right there in the double dollar signs. So here's the question D right there with the equation. If you want, you could add the regular, the $2 signs on it, and now it'll display below it. So you can see it. That is 1 over y to the second power. So think about this. What are we going to have to do to this one? Oh, knit to Word. Always knit to Word. I knit to HTML just to knit faster. I knit to HTML just to knit faster. What would need to happen to this to fix this? Think about the process if you have 1 over y squared. What is the process of fixing this? What is the process of solving for y? What is the process? So if you have 1 over y squared, fixing it is going to involve what process? 1 over y squared. How would you solve for y? And then we're going to do 201. The question is, but ask more questions, 320. So I got 201 questions right after this. How are you going to fix this one? Thoughts on fixing it? Because you want to solve for y. So how can you solve for y? Root it? I wouldn't root it first, but that is, yes, I'd root it, but I'd first what it. I'd take the whole thing and what it. You could either which order, I guess. I'd reciprocal then inverse it, or oh my gosh, I'd flip it. I just say flip it because if you flip both sides of the equation, it's still mathematically the same. So you can just flip the equation and then root it, and then you're done. I'll show you this one right here. We'll just do it. So remember what we said? We're going to flip it, then root it. So there's the equation, right? So now to flip it and root it, you take your equation right here and you flip it. And to flip it, you just do 1 divided now. Be careful. You want to do 1 divided by, and everything needs to be over this right here. Does that make sense? 1 divided by this, and you flip to the whole thing. How does that look right there? No, yeah, I'll show this one right here. And there's the Untransformation primer in the notes, so check out the notes on it. But does that make sense that I have now flipped that right there? How's that look? Does that make sense right there? It's now flipped. All I did was take the equation here, and I just flipped it. I just took it, flipped it. So you just take it and go whoop, and everything that was on top is on bottom. Everything on bottom is now top. So with this now that we have it, so you notice it's 1 over y squared. The y squared flips to the top, and 1 plus x to the fourth, that's on the bottom. So it's now 1 over 1 plus x to the fourth. This is now 1 over this, and the y squared has now flipped to the top because if you flip this, the 1 goes to the bottom. If you flip this right here, the 1 is going to go to the top because it could be just 1 plus x4 over 1. It would be the same thing right there. So now what we need to do is we need to square root it. The easiest way to do this is just to type SQRT and put the quantity inside of this. That's one way of doing it. It looks fine like that. But if you want to be real fancy, and that's going to remove the squaring of this, because if we square root both sides, we get this right here. If you want to be fancy, you put it inside of the squiggly brackets, and that should do it. Oh, no. I thought it was SQRT. SQR? Square root in LaTeX. LaTeX square root. Oh, it's backslash. Oh my gosh. You got to call it backslash. There we go. And now it's mad. There we go. You have to call the backslash to get the code right there. You can also do fractions and make them look nicer. To do the fraction, we just take this right here. This is just making it look all fancy. And there's that. And I think it just does it if you do that. LaTeX division / divide. No. How do we get? Here we go. 2 seconds. I want to make this look pretty. I am on. Let me show you the page I'm on. Because I don't do a bunch of LaTeX. It's frac. That's what it is. /frac. So here's a page with all the LaTeX things to make it look all pretty, like plus or minus, the dot, the C dot, the times right there. So you can go to all the symbols. This is the way a lot of scientific papers are written. So we want frac for fraction right there. And it's super mad at me. What did I break? Oh, that's the square root. We want right here /frac. And we don't want the divide anymore. Ooh. There we go. All right, so that's the prettiest we can make it. You don't have to worry about making it look super duper pretty, but this right here, that's the great thing about using LaTeX a little bit, is it can make it look nice and neat. We're not here to learn how to write LaTeX though, but if you want, the thing I put right here from wherever this is at, basic code in LaTeX right there. Any last thoughts on this right here? Nice and pretty equation. So if you can look right here, we've got the original 1 over y squared is equal to 1 plus x to the fourth. We flipped it, put the y on top. We square rooted it, so the y is no longer in squared units. So the other side gets square rooted. How's this looking right here on doing the untransform right here and doing these sorts of things? What are your thoughts 320? And let me know any other questions because we've got two 201 questions. So throw me those 320 questions because we're hopping over to 201 here in a second. What questions are there? I'm confused about the stat project. I look in the syllabus, but do we need to start that? The stat project should be coming out here soon. The data analytics projects are what we do throughout the semester, and then we get to a big stats project, which we'll be sending out info about that. So the data analytics are kind of your pacing. Juliana, thank you so much for asking. The data analytics assignments are the pacing, and then the stat project is kind of the big one that we do towards the end when we get a lot of skills and ready to go. So the data analytics are going to help you pace. Let me throw you 1,000 points. Keep asking those questions. Let me know what you're wondering. The stats project is not out yet. We're doing all the pacing. Let's over to the main screen. Okay, good work right there. 320, ask all those questions. Let's see. Got all the chats open from today. Okay, we've got some 201 questions. We're still trying to get 201 synced. They're like, delete this, undelete this, remove this. And I'm like, none of your suggestions are working. I need to talk to them on the phone tomorrow. Tomorrow's my less busy day. Less busy day. Whew. I think my parents just had their anniversary and I forgot to wish them a happy anniversary. Where is that? I'll figure that out. Chapter 12 homework is the first one. And the question is something about landline surveys. There we go. Thank you, Taylor. Where is the landline surveys? Ah, here we go. This is a good one. This is a tough one. Let's try it again. This is my question. Thank you so much, Taylor, right there. Okay. 22, 43. Here we go. Let's do it. Okay. So this one is all about probability. And this chapter is very, very, very mathy. So check out yesterday's office hours. We did a lot of these questions. Also check out today. That's why I'm here to do a few more. Let me know which ones you're working on. A 2015 study found out that 51% of households had no landline service. This raises concerns about the accuracy of certain surveys as they depend on landline numbers. Researchers picked 13 U.S. households at random. Okay. So what percent of households have no landline service? Just repeat back to me. What percent of households have no landline service? So we have to know what the question said. The percent of households with no landline. 51%. So what's the probability a house has a landline? What is the probability that a house has a landline? So 51% don't have a landline. 49% have a landline. Does it make sense what I've written right here? The probability of landline is 49%. The probability of not landline is 51%. So for this question, let's see what it asks. We take 13 households. What is the probability that all 13 households have a landline? So if you were to imagine this, and you knock on the first door, just a random house, you knock on their door, and what would they tell you about having a landline? If we look at the probability of all 13 households having a landline, what would they tell you? If you go to 13 households and you knock on the first random door, they're going to be random. You're not going to pick all these houses in a row right here. If you go to 13 houses, what is the first one going to tell you about having a landline if all 13 have landlines? They're going to say, yes, we have one. How about the next one? If all 13 have landlines, the first has a landline, and the second, and the third, and the fourth, and the fifth, and all the way to the 13th. So if we randomly sample and choose random households across the U.S., every house would be what of another house having a landline? And we're taking random 13 houses. Every house would be what of another house having a landline if they're just randomly taken? Random 13 houses. This house and this house are what? And they're completely random. So each house would be what? And the answer is kind of a hint by what I'm doing with it over here visually. Every house, if we take 13 random houses, would be what of each other? Every house would be completely what of the previous house having a landline. We just take a random house. We say, okay, let's look at this house. Do you have a landline? They say yes. We say, ooh. We take another house and we say, do you have a landline? They say yes. Every single house we pick would be completely what of another house having a landline? Rock knows.
It doesn't matter.
What does that mean? What does it mean that it doesn't matter that the previous house had a landline? Each house, and I'm multiplying, which is a hint, each house having a landline is completely independent. Great job, Meredith, right there. Each house having a landline is completely independent. And independence allows us to do the rule of multiplication, to say that if we have independent events, we can multiply them together to find out the probability of them occurring in a row. So here we are with the rule of the check of independence to multiply events. So how can we find out the probability of 13 houses in a row all having landlines? What would this be mathematically? Great job, Sarah and Meredith. So what would this be mathematically to figure out the probability of 13 houses in a row all having a landline, where the probability of one house having it is 0.49? So you can abbreviate it because it's going to be a lot to write out. But you could also do a ... after a few. What would it be mathematically to figure out the probability that 13 houses in a row all have landlines? What would it be? So the first has a landline, and the second has a landline, and the third, and the fourth, and the fifth, and the sixth. Exactly, Sarah. It's going to be 0.49 times 0.49 times 0.49 times 0.49 times 0.49 times 0.49. And you're going to keep doing that so it's easier to abbreviate. What is 0.49 to the 13th power?
That would be approximately 9.3874 times 10 to the negative fifth power.
Well, 0.00009. Wow, that's tiny. Basically, it's very, very, very unlikely. So it wants to 5 digits, and I think it's basically the 5th digit's a 9. And we're going to double check. Go over here to, well, I'm going to do it in R, because R makes things nice and easy. 0.49 to the 13th power. As long as you solve it, you can Google it. And there it is right there. That confirms our answer. 0.49 to the 13th power. So let's check. Yay! What is the probability at least one of them does not have a landline? So here's the interesting thing. Either all of them have a landline, or at least one of them does not have a landline. If you have 4 friends, there's 5 of you. Does everyone agree to that? If you have 4 friends, there would be 5 of you, including your friends. Does everyone agree to that? Meredith, you're on the right track for this. Yep, this is what we're going to do right here. Exactly, Meredith. So if you have 4 friends, there's 5 people. And it'll either be the case that all of you will make an A in Stat 201, or at least one of you will not make an A. Does that make sense for me to say it? There's 5 of you, and you're all taking Stat 201. So it is either the case that all 5 of you will make A's, or at least one of you will not make an A. Because that's everything that could occur. Either everyone's going to make A's, or at least one person won't make an A. So when we think about this right here, we just found out the probability, and let's write this down here mathematically. It is either the case that all houses have landlines, or at least one doesn't. If this is the case that one of these must be true, so Meredith right there, what would these add up to mathematically? If we say one of these things must be true because either it is the case that all the houses have landlines, or at least one doesn't have a landline, what would this add up to mathematically? Because one of these things must be true. It's either everyone's going to have landlines, or at least one of those houses won't have landlines. So what would this add up to mathematically, which Meredith has right there? Oh, you want to go over question 4? Which one? We did transformations just a moment ago. Is it the transformation one, I think? Well, this one won't be that, though. That might be the last one, I think. So this will add up to 1. Does that make sense? This will add up to 1 right here, because it is either the case, like when we say one of these things must occur, 100% probability, it is either the case that they all have landlines, or at least one of them doesn't have landlines. So we want to solve right now mathematically. How can we get this? How can we get this right here? How can we get that probability right there? How can we solve for the probability at least one doesn't have a landline? How would we mathematically get that? Because we want to solve for this. That's the one I'm interested in. I want to figure out the probability at least one doesn't have a landline. Well, so subtract from one. So we want to find out the probability at least one doesn't have a landline. And that would be everything but everyone having landlines. Because it is either the case that all houses have landlines or at least one, the previous answer. Because if everyone doesn't have landlines, then at least one person doesn't have a landline. Well, it's not going to be 0.49 to the all houses having landlines is correct. I think, yeah. I was double checking right here. The probability of all the houses, let's see here, the probability of having a landline is 0.49. So it'd be 1 minus the probability of all the houses having landlines, which was the previous answer. Good work right there. Let's throw some points. Great work following along. Oh, I got the thing in the chat. Does that make sense right there? It's 1 minus the probability of all the houses having landlines is the probability at least one doesn't have a landline, because it's either the case that they all have landlines or at least one doesn't have a landline. So that is the math right there. It's a tricky one. And we're just going to take this answer right here and do 1 minus it. So if we take and go 1 minus and just make sure, there's my points. Right there. And the other one is the opposite. Well, the complement. Great answers right there. We call them complements of each other because they add up to 1. And make sure to round this right here. That should be the complement as long. Yep, good. I get worried sometimes a little bit too. That's the complement because it's either the case that they all have landlines or at least one doesn't have a landline. So this one says, what is the probability that at least one of them does have a landline? So it's either the case. So finish my sentence. You ready right here? It's either the case that at least one has a landline or what? It is. I want you to tell me everything that could occur here. You ready? It's either the case that at least one has a landline or what? It's either the case that at least one has a landline or what? You have to phrase it that way to think about complements right there. It's either the case. Oh, question 2? Do some question 2. It's either the case that at least one has a landline or what? What would be the complement of at least one having a landline? Is either the case that at least one has a landline or what? Or none, exactly, Meredith. That's exactly it. So let's write that. You ready? So now we have at least one has a landline. Great job, Meredith. At least one has landline. Or, so that's plus, none have landline. What is going to be the easy thing to find right here? So that equals 1 because it is either the case that at least one has a landline or none have a landline. What is going to be the easy thing to find right here mathematically? So what is, because we want to find at least one has a landline, right? That's what it wanted us to find. It said, what's the probability at least one has a landline? So let's just algebra this over to the other side. And what's the probability none have a landline? The probability of not having a landline was 51%. So what's the probability all 13 don't have a landline? So what is the probability all 13 don't have a landline? So if one person's probability of not having a landline is 51%, that's what the problem said to start. What's the probability of all 13? Exactly, Meredith. Yep. And then 1 minus because we're doing the complement of it. Great job. This is a tough one. This is like the extent of like putting all the pieces together using complements, using multiplication rules, and understanding just how to talk about probabilities. Like this, these are the toughest questions on the test. So it's going to be 1 minus, and then we could just take the probability here. Once again, you can plug it into your calculators. I just like using R because then I can see what I do. And there's the probability. Yeah, because it is, yeah. My gosh, tiny, tiny decimals. What's up, Jay? 5 decimals. Woo! That's a good tough one right there. We got one more stat to one, but keep asking those questions. Question 2. I think we did some question 4, and then we got question 2 right here. Look at some question 2. So BAS 320, question 2. I think that's Q4. Question 2 on the assignment 7. Okay, let's take a look at the next question. Here we go. Drop those questions. Good work. If you can do those questions, you understand some really good stuff for the test. The next question on 201 is, Mary, keep dropping those questions. We only have one more question after this, is the American Red Cross quiz question. The American Red Cross, which I don't think we've done that one yet. It's a really great question right there. The American Red Cross. Let's take a look at the American Red Cross. And here we go. We're going to find it. I think it's towards the end of it. American Red Cross, here we go. A consumer organization estimates. Oh yeah, the car questions, let's do those. Does yours say you own 2 cars or is it the same car? Is it 2 cars or is it the same car, Meredith? Is it 2 cars or the same car? Like when it says like your 2 cars or your 1 car, because there's 2 versions of it. Let's go right here. No worries. Let's do the American Red Cross one. Nervous kicker? Yeah, we do nervous kicker. Tap roll quiz, nervous kicker. Of course, of course. Nervous kicker. A car is chosen at random, so it looks like 1 car. So we'll do the 1 car version. Okay, here we go with the. This looks to be some addition to me. We've got here the American Red Cross finds out that 44.8% of people have O blood. 39.5% have type A blood, 11.3% have type B, and the rest are AB. So what you immediately want to do with this is you want to start writing this out and putting it into a table for ease of figuring out answers. So a proper probability table will add up to what percent or what as a number. If we have the event right here, so we could call it the event E and the probability of an event. You can call it whatever you want, just probability on one side, event on the other. 1, exactly, Alexander, great work. So we have somebody has blood type O, which is just an event or outcome. We have A right there. We have B, and then we have AB down here on the bottom. Can anyone go ahead and help solve for the probability of AB? That's going to be the tougher one. 44.8 right there, 39.5, 11.3. So 0.5, my brain. Let's find out. I'm gonna use calculator. It's gonna be about 6%, right? 6%? That's a guess. Yeah, pretty close. Not super far off. 4.4? Tell me if I got that wrong. 4.4. I just did a really quick guess at 6, so it's like, looks about close to 94, 95. So there it is, 4.4% have type AB blood, according to the American Red Cross. How did we figure that out? I took these values and did what? And then did what from them? For it to be a proper probability table, how did I figure out this missing probability that it didn't give us? How was I able to figure out? Because I know I can do what? How was I able to figure out that missing probability right there? How was that? How did we find that out? Whatever that value is will add up to 100%. That needs to add up to 100% or 1 if you do it as a decimal, whichever way you choose. So now, what is the probability of AB blood? Immediately we get that question. I think it was 4.4, and it says to 3 decimals. How does it want these? It's giving it as percents. Little worried. Does it want it as percents or decimals? See, it says to 3 decimals. So I really think, and I don't like that it's doing this, I really think it wants like this. I haven't done this one lately. Because it says 3 decimals. And the way we found that is we added up, and this would be 0.044 as a decimal, just divide by 100. And probability right there. If it wants 3 decimals, everything else is to 1. What is the probability that a donor has type A or B? Having type A and type B blood, now please answer this question, are what outcomes? Because you can't have type A and type B. I'm telling you that they are what of each other. Having type A or B are very what? having type A or type B are what of each other? So if you have type A or type B, those are very, very what outcomes? They're actually super dependent. They're super dependent and they're very this. So if you have type A, you can't have type B blood. So I'm telling you what by doing this right here. If you have type A, and good answers, we're going to have 1,000 points. If you have type A, you can't have type B blood. I know you could have type AB, but if you have type A, you're not type B. They're disjoint. And disjoint events are very dependent. Like having type A depends on having type B. So it's very dependent. Your blood type is very dependent on not having a certain blood type. So because they're disjoint, we can do what with these probabilities very easily. Because they are disjoint, we can do what with these probabilities. Hence, this is a great review right here. Because they are disjoint, we can easily do what? And notice the key word right there. Because they are disjoint, we can easily what these probabilities. Since they are disjoint, we can very easily what them. Just add them like that. So disjoint means there's no overlap. There's no point at which someone has A, B blood, as in A and B blood. So the A, B, all we do right here is go to the values of 39.5 and the values of 11.3, add them, and then change to decimal by going to 0 point and removing the decimal. That should be right. What is the probability of not O? This is asking for the what of O blood. Starts with a C. The not O blood is going to be 1 minus, and what is that in terms of language by which we talk about it? The not O blood is called the what? Hey, Snea, good to see you here. Let's throw some 5,000 points for a random Snea up here and give Snea shout-outs right there. Snea of the famous Snea level right there. When we say not O blood, we're talking about what's. When we say not O blood, we're talking about what's right there. Not O blood, we're talking about the what. So if we say not O blood, compliments, yes, with an E, not an I. So all you do is you go to O blood and you say, well, we want not O. So you go 1 minus. Make sure to type it in the right way. And there we go right there, 1 minus everything else. It's like you're either O or not O. I think we're going to do 2 people right here. 4 potential donors. So the first person is O and the second person is O. And these are random people. The first person is O, and the second person is O, and the third person is O, and the fourth person is O. The probability of O blood is 0.448. So what is the probability the first person is O, and the second, and the third, and the fourth? Like they're O, and O, and O, and O, and they're all random independent individuals. What is the probability that the first person is O, and the second, and the third, and the fourth? What would that be mathematically? The first is O, and the second is O, and the third is O, and the fourth is O. What's the probability of O blood, and O blood, and O blood, and O blood? And the probability of O blood is 0.0448, right? Or I messed it up. Look at Zoe Warren now. She's oh my gosh. You kill me. 0.0448. Oh my gosh. Oh, you kill me. You kill me in the chat. So what's the probability of O blood, O blood, O blood, O blood? What is the probability of O blood, O blood, O blood, O blood? Sounds like a MCR song. Give me blood, blood. Exactly, Alexandra right there. Little MCR in the chat. 2, 3, 4. That's to the 4th power right there. Let's take and see what decimals it wants. To 3 decimals right here. MCR for post-Halloween today. The probability that no one is type A blood. So talk to me about the first person who walked into our clinic. The first person who walked into our clinic was what? There's 4 people who walk into our clinic. And the first person was what? Just imagine this happening. The first person walked in. No one was type A blood. So the first AB, excuse me. No one was type AB blood. So the first person who walked in was what? Not AB. So what is the probability of not AB? What is the probability of not AB? So just first find out the probability of not AB. What's the probability of not being AB? What's the probability of not being AB? So either someone, great job. So that's the probability of not AB. So what's the probability the first person's not AB, and the second person's not AB, and the third person's not AB, and the fourth person's not AB? Random people walking in independent of each other, mentioning the multiplication rule right there. So what's probably the first person's not AB, and the second person's not AB, and the third person's not AB, and the fourth person's not AB? What's the probability of that? Very similar to the previous work we just did. Just raise it to the fourth. 2, 3, 4. There we go. That's it right there. Zach, great job, Alexander, and great work. We'll throw you some more points in a second, but great job on practicing it. These are tougher questions. Hopefully I don't miss anything. You never know. The probability that they are all, oh my gosh, the way this is worded. The probability that they are not all type A. Okay. Okay, so either they'll all be type A or they will not all be type A. Does that make sense what I just said right there? Either every one of them will have type A blood or they will not all be type A. Yeah, you're welcome. These are tough questions. So either every one of them will be type A blood or they'll not all be type A. Does that make sense? Either they'll all have type A blood or they'll not all have type A blood. So let's write this out. The way it works is either it is the case all type A or not all type A. We are interested in finding not all type A. So what should we do here mathematically? So we are interested in finding not all type A. We want to find the probability of not all type, because either all 4 of them will have type A blood, or it is the case that not all 4 of them will have type A blood. There'll be at least one that doesn't have type A blood, or they'll all have type A blood. So what do we do right here? If we're interested in not all type A, we can go here and subtract an algebra like that. 1 minus all type A, exactly. So what's the probability of all type A blood? So can you tell me the probability of all type A blood from the table right here? Great job, Caden. What is the probability every single one of them has type A blood? So use this table to figure out the probability that all 4 people who walk in have type A blood. Right, the first person walks in, type A blood. Second person walks in, type A blood. Third person walks in, type A blood. Fourth person walks in, type A blood. Or first has type A blood, and second has type A blood, and third has type A blood, and fourth has type A blood. Keywords right there if you hear me saying it, because I'm talking about this right here. What is the probability the first has type A blood, and the second has type A blood, and the third and the fourth? Very similar to what we're doing continuously throughout this. Exactly. And then make sure to do it as a decimal, though. I think maybe I should have mentioned that earlier. Make sure to do these as decimals. So when you go here, is that 2, 3, 4? And that should be it right there. Great job, Caden, right there. And just make sure to do them as decimals. Yep. I figure sometimes people are doing that. And then what's probably that they are not all type A blood? That should be right. I'm a little scared. These are tough questions. Got around them. What is the probability that at least one person is type B? Well, that sounds about the same. So what is the probability that at least one person is type B? So there'll either be at least one person with type B blood or what? So think about what the complement of this is. There'll either be at least one person with type B or what? There'll either be at least one person with type B or what? Finish that sentence. There'll either be at least one person, at least one with B, or what's the end of that sentence? There'll either be at least one person who has type B blood or what? So there'll either be at least one person who has type B blood or what? At least one person has type B blood or what? So either there's 4 people walk in and either at least one of them will have type B blood or what? What's the complement of at least one having type B blood? Well, so at least one could be one of them has it, 2, 3, or 4. So what did I not mention right here? So it could be one has it over here, 2, 3, 4. At least one of them has B blood or what? What is the only thing I didn't mention? There's at least one of them with type B, or what? Or none, exactly. Or none have B. So the thing we're trying to find is at least one has type B blood. We want to find that. So why don't we just take this right here and algebra this over to the other side right here? So if we algebra this over, we have to minus it. So now we have to find out, and Shreya's got the crazy points. Now we have to find, I mean, Snea, I said Shreya right there, Snea. Sorry, Snea. We have to take right here and find the probability none have type B blood. So the first person walks in, doesn't have type B blood. The second person walks in, doesn't have type B blood. The third person walks in, doesn't have type B blood. The fourth person walks in, doesn't have type B blood. So what is that right there going to be mathematically? What is the probability of the first person walking in and not having type B blood? So find that right now. What is the probability the first person walks in and does not have type B blood? What is the probability the first person walks in and does not have type B blood? What is that probability? They walk in and they don't have type B blood. First person walks in, doesn't have type B blood. That is correct, I think, because you're doing 1 minus. Great job, I got it set up. There we go. There's the probability of not having type B blood. First person does not have type B blood, and the second, and the third, and the fourth, and that's the probability they all don't have type B blood. So now we just do 1 minus that, because we just found the probability of everybody not having type B blood. So 1 minus that is going to be the probability at least one has type B blood. So it's a complement of a complement. And there it is right there. That's the probability at least one, because this is the probability none of them have type B blood. 1 minus that is at least one has type B blood. Whew, we did a lot of these. A lot of work, a lot of rounding. Don't you tell me I got one wrong, my Pearson. Don't you do that. Oh my gosh, I knew it, my Pearson. What are you doing to me? Where did we make our decimal error? Nope. This one? Really? Okay. The probability that they are not all type A. Probability that they are not all type A. So either they're all type A or they're not all type A. What's the probability of type A? Type A is that. 2, 3, 4. Oh my gosh, we forgot to take the complement. That's the probability they are all type A. This is the probability they're not all type A. We forgot to take the complement of that. So sorry about that right there. That is it's a step-by-step. We found the probability they are all type A. We want the probability they're not all type A. Does everyone see that little errors, big mistakes? This was a marathon of a question. This is a tough one, and it's very easy to make a small error. Yes, so when you so I'll show you the math again on it real quick. So the probability of them all being type A is what? And I just didn't do the not all type A. So the probability of them all being type A is what? So to find the probability of everyone being type A, it's what? So here's the probability of type A. So what's the probability of everybody is type A? 4 people walk in and they're all type A. So what's the probability 4 people walk in and they're all type A? What would be the probability 4 people walk in, and it is that, and that's when we raise it to the 4th power. So that's 2, 3, 4. So that's 0.395 to the 4th power right there. Does that make sense? The first person is type A, and the second, and the third, and the fourth. Does that make sense? And now we want to find out they're not all type A. So what do we do to this probability to say either they're all type A, that probability on the screen, or they're not all type A? So then what do we do to this to find out the probability they're not all type A? To say either they are all type A, which is a very small probability, and then we do 1 minus right here to say they're not all type A, because either they're all type A or they're not all type A. This is a great question. I'm so bummed I forgot the one last step of subtracting from 1. We wrote that down. There it is right there. I stopped at that because we were trying to find, I highlighted this, and this is what we were interested in. So this probability right here, there's the other part of it. We wanted this right here, and we'll delete down some decimals. I just went to the next question. Darn it. We're so close. Really good question. I was like, we got this. There it is right there. The probability they are all type A is 0.0244. The probability they're not all type A is 0.976. which is the complement of either they are all type A or they're not all type A, because one of those things must occur. Really, and I just hate, because this is such a good question. No ban this question right here, because this question right here is this question is the whole chapter basically. It's got the addition rule to start. It's got complements. It's got multiplication. If you can master this question and understand the wording of it and do the complexity of it, it's got a proper probability distribution. This question is the whole chapter basically. I'd say it's 80, 90%. It doesn't talk about trials, outcomes, events, but it uses those sort of ideas. It doesn't talk about law of large numbers, but it's got the majority of what the chapter covers in it. Really great question. I know sometimes we say ban this question, but don't ban this question. Learn how to do this question, learn how to understand it, learn how probability distributions work. And if you understand this question, you understand things like the multiplication rule right here, where two things need to be independent, i.e. random people walking into the Red Cross clinic. You understand the addition rule, where things have to be disjoint, like you can't have type A and B blood at the same time. You can have AB, but not type A and type B blood. And then the rule of complement, meaning that we can do 1 minus to find not the event. Really good question. I think we have another My Pearson one. Here we're going to do 2 more My Pearson's ones. I'll hop back to 320. So stay tuned, 320. Oh man, do we not mark? Oh, I'll go find where that's at. I didn't mark it. I'm going to put the time in there as question marks. How did I not mark that time? That was like a 20-minute question. A consumer organization. Where is a consumer organization? A little chill music right here. Nervous kicker. We'll do nervous kicker first. Okay, stat tool 1. Here we go with the nervous kicker question. A nervous kicker usually makes about 72% of their field goal attempts. Ooh, Meredith. Nice. If he makes his first attempt, his success rate is, this is like saying if they make their first, then they have a 90% success rate. What is the probability he makes his first 2 kicks? Okay. So the probability that the kicker makes his first 2 kicks is what? So what's the probability he makes his first kick? So just put this one thing. I think Meredith's got the answer. What's the probability he makes his first kick? 72%. So if he makes that kick, now this is where it actually depends. Like his probability actually increases. So now he gets like a confidence boost. He's like, yeah, I got this. So now the probability of making the second kick is 90%. So it's telling you there's a different probability, because the probability of the second kick actually depends on the first, but they're giving it to you. So you can do your sports right here and just go 0.72 times 0.90. And that's going to be the probability they make the first and the second kick. Wow, I love it. I love it when we go from like one of the most difficult questions to one of the easier ones. But thank you so much for asking this right here. A good kind of question to get started on, to practice, to understand. It's giving both probabilities and we can multiply them together. And let's do the consumer car organization one. That one's a little bit longer. This is an interesting one right here. I think it's very similar. Where's the football one? You're welcome, Caden, anytime. And great job practicing along. I'm just going to bounce around the questions. Now, where's the consumer car? It's on here somewhere. Is it only on the homework? Lots of questions. We did that one yesterday too. Oh, the light bulb one. These are good. It's on the quiz. Where is it? Here we go. You don't have the 2-car version, right? You have the 1-car. You give the 1-car version. So if you are looking, let me take a time to stamp on this. Not that one. It's this is the first one, right? Is this right, Meredith? Right here. The one chosen at random. Yeah. So this is 1-car. This is a little bit different. Okay. So let me take the timestamp right here, right on the 1 hour mark. Okay. And then we're gonna do a little more 320 after this. Chase, good to see you here. Okay. So the first thing you want to do if you get this is to write out the probabilities. So we're going to take this information right here and write out the probabilities. Go away, calculator. We don't want you anymore. So with these probabilities, Here we go. These are the probabilities associated with your car being repaired either 1 time, 2 times, 3 plus, or 0. So the probability of the event, and the event being 0 repairs, 1 repair, 2 repairs, or 3 plus repairs. What is the probability? 2015? Yeah, we'll do one. You got it. Might do one next and then hop to 320. What is the probability your car gets repaired 0 times? No, let's not do 0 first. That's the one you have to find. What's the probability your car gets 3 or more repairs? What is the probability your car gets 3 or more repairs? What is the It's 2%. Great job. 2% right there. What is the probability your car gets 2 repairs? 2 repairs is going to be up there at 9%. What's probability your car gets 1 repair? And now we can find the 0 repairs by finishing the table and figuring what this adds up to. And that's 70% because we're going to subtract from 100. There it is, right? Does that make sense? So the missing 1 in this table is 0 repairs. So you can find all the values, and knowing that the probability table must add up to 100, you can get right here, because this is actually one of the first rules of probability. It's kind of the putting all the rules together, that the sum, or it's the second rule rather, the sum of all probabilities is equal to 1. So the probability of no repairs is going to be, if we add everything up, the no repairs must have a 70% probability because it has to add up to 1. So the probability of no repairs is going to be the complement of all the repairs. What is the probability that the car will require no more than 1 repair? No more than 1 repair. So no more than 1 repair would be this many or this many repairs. No more than 1 repair would be your car got this many or this many repairs. No more than 1. My car did not get more than 1 repairs last year. That's true. So your car either got this or this many repairs. No more than 1. So if your car got no more than 1 repairs, it either got this or this many repairs. Be careful, no more than 1. So what would that be? How many or how many repairs? Yep. And that won't equal to 1 though, because those aren't complements. But good, that's basically it. You're just going to take and add them because they're disjoint. Does that make sense right there? You can just add together these right here and get 89% or 0.89. So it's your car either got no repairs or 1 repair. And so those aren't complements though, because you could get 2 or 3 plus repairs. So your car either gets no repairs or 1 repair, which would mean your car got no more than 1 repairs. Add those up right there because they are disjoint. Your car can't get 0 and 1 repairs at the same time. The probability the car will require some repairs, what's the probability of that? And think about this. This is complements. Your car either gets no repairs or some repairs. So you should be able to visually see pretty quickly. Your car either gets no repairs or your car gets some repairs. And if you're looking for the second version of this question, check out yesterday's office hours. The second version is available. I think I labeled it version 1 or version 2. So, and you are correct, this will add up to 1. So what would be the probability of some repairs? Your car either gets no repairs or some repairs. So it's easy. If we look at the no repairs, we can find the probability of some repairs. What's the probability of some repairs? And we want to find this probability right here, which we can add those up. 0.3, that's exactly it, because your car either gets no repairs or some repairs. So the probability of getting some repairs is the complement of no repairs right there. So that's the addition rule and the complement rule. Just make sure to not put the numbers in wrong, and you should get it right. Great job. We'll do one more right here, and then we're hopping back to 320. What was the one? It was just mentioned a second ago. I know it. Once you see it, it's like, wait a minute, that wasn't bad. No, Meredith, thank you. Don't worry. That's what I like. I want people to say it's easy. Sometimes people say, wait, I still don't get it. That's impossible. But I want people to say, like, wait, that was easy. Wait, I understand that. If you say it's easy, that means you get it. What if I told you everything we do in Stats 1 is easy for me? I may make a lot of errors. Errors happen. But what if I told you everything we do in Stats 1 is easy? You'd be like, you're crazy. And I'd be like, well, it's easy because I've done it a bunch of times. I needed that too, trust. Thank you so much. We'll throw another 1,000 points. It's only easy if you practice it and you start to understand it. Then it's easy. You tell a 5-year-old, algebra's easy. And they're like, are you crazy? Probably. Good to see you, Alexandra and Caden right there. So just remember, it gets easier with practice. And as soon as you start getting this And the number one thing to do, especially with a lot of these, is to write down the table of probabilities. The table of probabilities is really going to help you see what's going on right here. Well, we can see the probability of no repairs means you got 0 repairs. Some repairs is 30% by adding those up. And we also saw the probability of no more than 1 repair right there. I think the last one, and we can do more, we can come back to this, the 2015 survey, and then we're going to do a little 320 on the in-between. So let's go find that one. Do remember we did a lot more yesterday, so if your question is not in this video, it might be in yesterday's video. I keep giving those advertisements for yesterday. This is one of my favorite chapters. I'm so bummed we missed that Red Cross one. I was like, come on, we got it. We did everything right. Oh, I forgot to do -1 on one thing. That's where you got to go back and do more practice. Ooh, we did the bowler one yesterday. That was fun. I literally, like, I'll forget to, like, click one question and it won't be it. 2015. Is it literally, like, the last question on here? Nice job, Meredith. Let's throw everyone 10,000 points for Meredith getting that 100. That positivity right there, Meredith. Great job conquering a challenging mathematical chapter. Huge shout outs right here. We got another one with a bunch of using the complement rule right here too. And really, Meredith, great work. This one's very easy. I've already made one error today. I'd get like a 98 or something. Congratulations and great work, Meredith. So let's take a look at this question right here. So there's a way I'm going to phrase this question to make it a lot easier. So I'm reading it a little bit differently. You ready for the question? 71% of adults have cell phones. Let me just repeat it to you again. What percent of adults have cell phones? Don't worry about reading the full question. I'm making this question a lot easier, and I don't think I took the timestamp. I didn't. Let me take the timestamp. So the easy way to read this question is 71% of adults have cell phones. That's all we really need to focus on for this question. So what percent of adults have cell phones? You can just say adults. Don't worry about the whole 25 to 29. That won't come into play in this. It's more context. All data needs context. But let's just say 71% of adults have cell phones. 71%. So let's use this information to see about randomly selected adults. So we are going to take right here, let's see right here, we're going to take 8 adults. What is the probability that all of the adults have cell phones? Remember, I'm just abbreviating it as having a cell phone. Don't worry about the landline portion. So if you walk up to the first adult, what would they tell you about having a cell phone? So 71% of adults have cell phones. And what's the probability that 8 adults, randomly chosen, have cell phones? The hint for this, and we'll bring up the slides, is to use the following. We would have to assume that these are randomly selected adults and each adult is independent. So the first adult having a cell phone would be what probability? What would be the probability of the first adult having a cell phone? The probability the first adult has a cell phone would be what? It's a lot of repeat. That's a lot of repeat questions. What's the probability the first adult has a cell phone? You just walk up to a randomly selected adult. Hey, do you have a cell phone? The probability they have a cell phone is what? What would be the probability that randomly selected adult has a cell phone? 71%. And then the next adult, who is completely independent of that first adult, you say, okay, thank you for talking to me. And then the next adult has a probability of what? Some hints up at the top. The next adult has a probability of what? And then the next adult has a probability, not 10%. The next adult has a probability of what? First adult has a probability of 71%. Next adult has a probability of 71%. So we need to have the first have a cell phone, and the second, and the third, and the fourth, and the fifth, and the sixth, and the seventh, and the eighth. I think it's 8. What is the mathematical way to find this, to find the probability that all 8 adults right there? So what are we going to do with that? What's the easy way to abbreviate that? 0.71, 2, 3, 4, 5, 6, 7, 8. And I'm not going to get another question wrong today. I'm going to check it with R by doing the following. And there it is. And that confirms the answer on the screen. So and make sure it's 0.71. Make sure to do it as a decimal right there. Great job, Taylor. Excellent work. 0.71 to the 8th power is the probability. And delete your decimals. Round up. You better not tell me I'm wrong on this. So 0.71 to the 8th power. And check my work as I do it. It's easy to make errors. So now we have, what is the probability that none of the adults have a cell phone? Don't worry about the whole landline thing. That's just extra accoutrements. So the first adult doesn't have a cell phone. And the second adult doesn't have a cell phone, and the third adult doesn't have a cell phone. What is the probability that first adult does not have a cell phone? Use that up there to find the probability just the first adult you walk up to and say, do you have a cell phone? They say, no, I don't. Like, oh, that was weird. What's the probability the first adult doesn't have a cell phone? What is probably the first adult you walk up to says, no cell phone? What would be the probability of that? Just the first adult. 0.29. And then the second adult doesn't have a cell phone. And then the third, and then the fourth, and then the fifth, and then the sixth. Which one do you want to do, Santi? We're going to do a little 320 right after this because I've been promising that. And then let me know which one you want to do on the homework. We did a lot of homework during class yesterday too, so check that out. So what's the probability the first doesn't have a cell phone, and the second, and the third, and the fourth, and the fifth, and the sixth, and the seventh, and the eighth, all the way to there, and they're independent of each other, which you have to assume to multiply. So it would be the probability the first doesn't have a cell phone, and the second, and the third, and the fourth, and the fifth, and the sixth, and the seventh, and the eighth don't have cell phones. Very, very similar to the previous question. Yep, that's it. Great job, Chase, right there. So we just take 0.29 to the 8th power. And once again, type it in correctly. And whew, basically virtually impossible. Wouldn't that make sense? If you walked up to 8 people and they didn't have cell phones, that'd be virtually impossible. Like if 71% of people have cell phones, you walk up to 8 people, it'd be virtually impossible that 8 people in a row wouldn't have a cell phone. So kind of makes sense. What's the probability that at least one of the adults has a cell phone? Don't worry if it says only a cell phone. I'm just abbreviating it as cell phone. So either no one has a cell phone or at least one person has a cell phone. What should we do mathematically here to solve for this answer? Either no one has a cell phone or at least one person has a cell phone. Does that make sense? Because it says, what's the probability at least one adult has a cell phone? Just an easier way to understand the question than the way they word it. So either no one has a cell phone or at least one person has a cell phone. I'll write it down here while people are thinking that over. So it's either the case that no one has a cell phone or at least one does. And we want to find out the probability at least one does. So what could we do right here? Have we already found one of these probabilities? Have we already found one of these probabilities? We want to find the probability at least one person has a cell phone. What did we just find? So you have to think about how to phrase. This is the tough part. These are the complements, which are really tough. This is probably the toughest part of this chapter because it is either the case when you walk up to 8 people that none of them will have a cell phone. You see 8 people. Let's just say they're random people. If they're staying together, they're not truly random, but we'll pretend. You see 8 people. You walk up and say, "Does anyone have a cell phone?" It'll either be the case that none of them have a cell phone, or at least one of them does. Does that make sense? Like that is everything that could occur. Either none of them, they'll say no one here has a cell phone, or hey, at least one of us has a cell phone. So one of these things must occur, making them complements, and there's also no overlap because you can't have like 2 people have a cell phone and no one have a cell phone. It's going to be the case that like 2, which is at least one have a cell phone, or none have a cell phone. So now we are trying to solve for at least one. What was the probability of no one having a cell phone? Remember, the first person didn't have a cell phone, and the second, and the third, and the fourth, and the fifth, and the sixth. The probability of no one having a cell phone was the following. And we just found it a moment ago. Here, we'll do the raised to today. Raised to the 8th power. So that probability right there is the probability of no one having a cell phone. So now we simply solve for the probability on the left. And we already have this answer right here. So let's just take this answer right here and do 1 minus. And there's the probability of at least one. Because it's either the case that no one has a cell phone or at least one person has a cell phone. Woo! Scary question. Does that make sense right there, Taylor? It's either the case that no one has a cell phone or at least one person has a cell phone. So they're complements. And you can see the math right there, how they would add up to 1. Because one of those things must occur. Either no one's going to have a cell phone or at least one person's going to have a cell phone. So really good stuff. And Santi, let us know which question. We're going to do a little 320. It is Tom. Let me play the Celeste song. I like this song. Not for Celeste, but it sounds like it. I think people said question 2C. You're welcome. Have a great evening, Taylor, and great work. Tough quiz. Okay. Let's take a look right here at doing a little bit of, this is question 2, assignment 7. 115, 23. VS for 20. Let's hop over to the main screen. Okay. So we have right here, we are going to make a model where we've transformed the y variable and transformed the x variable. So when you do this, and I don't want to do the exact same thing right here. You should have like price equals some number raised to the area. We're predicting the price of a house based on the area of a house. Here's the data set, the EX3 housing data. And let's take a look. So when we make this model right here, so 2 points for defining the x variables. Yes. So, and this is from the homework packet. Make sure, I think someone was asking, I can't believe I just noticed your, yes, Nay, it's just been growing long. It's been getting crazy. So it's getting pretty crazy long right here. Give me flashbacks to Tool. Oh yeah, when I had my hair all the way to my shoulders. I'm seriously planning on cutting it because it keeps getting in my face and bugging me. So I keep planning on cutting it. And so I'm going to the homework packet right here. So let's go to the homework packet. Homework packet right here. And let's go check it out. Okay. And here we are, chapter 3. So question 2, chapter 3, page 127. Okay. There, here we go. A very common transformation is the log. Although it's not a common transformation to find the highest R squared, let's use it, or it might not be ours. Fit this transform model and examine the results of the visualized model using check regression. Are the statistical tests of the assumptions passed? If not, does it look like the linear regression model is appropriate for modeling this transformation? Why not? Let's do a little bit. We might just do this one here. We got enough time. And we should verify the regression equation. I think someone said that the regression equation wasn't coming out the same. So let's see if there's a problem with the data in the book. Good things right here. Okay, let's do it. So there's the data right there. And we want to define the y transformed variable and the x transformed. So we're going to take our slots right here to store them in. And there we go. So let's go log 10 of the EX3 housing data, and the y variable of interest is price, and that stores into that slot right there. And then we go here and we say area, and there's that because we're predicting the price from the area. Fit the transformed model right here, summary, or there's the, we haven't fit the model yet. Quick question, write your untransformed equation. It should be like price equals some number area. Yep, so you want to untransform the log 10 by doing the thing we did earlier to untransform. Don't worry about solving it out completely. Remember where we were untransforming using the log 10, and the point is to solve for the y variable. That sounds about right. Or, so EX3, maybe, wait, EX3, the way everything's stored right there, y1 equals... maybe you could probably do that, Zoe, right there. Which homework do you want to do, Santi? Let me know, and we can do that. Got time for a little more homework. So right here, we've got our x and our y stored. That didn't, no worries. You can check you have the same values by double clicking and seeing if you have the same values of the y at the end. So there's a little bit of a sanity check. And double click your x, make sure you have the same x values. That's just defining those and storing them into those areas. So now to fit the model, we have to run linear model y transformed tilde x transformed right there. 51% of people in certain homework. Yeah, let's check that out here next. Let me grab it. We'll do that one. That might be the last thing we do out here. 51%. There we go. And now we've got the model. And now how do we visualize our model? So these are the steps we want to make sure we know how to do. How do we visualize our model? To visualize the model, there you go. Not that bad. Not that bad. Looking pretty good, right? So I would say that this model, hopefully it doesn't completely fail everything. We'll find out. And how does it do? How does this model do on the conditions when you just look at the p-values? How does this model do on the conditions? How does that model do on the conditions? Very important to know this right here. You'll join me on Discord. Awesome. How does that model do on the conditions? Failed every condition. The linearity is, truthfully, the linearity doesn't look bad. The normality of residuals is one of the worst. Equal spread, meh. Normality of residuals is probably where the biggest problem is. How does the summary look? We have 1.21, and let me see right here. If we round this, can we round the summary? Round to 2 digits. It doesn't like round on around the summary. It doesn't like that. I think these are the same values though. 1.21. Let's look. Here it is. Nope, that's the wrong thing. There we go. And let's go back to R and there. So we have 1.2 there. These are the same values. So someone was mentioning earlier that they weren't getting the same values because this is log 10 price 1.21 plus 1.26. It's just that we have more values right here. 1.21 is right there, and 1.26 is if you round it up. Does that, so Meath, are you getting those same values right here? Probably go to options, digits, or something like this, and say digits 2. Will that fix it? No. Options SciPen. SciPen 2. And it does not. Options round. Does the round work? Yeah, it's doing that right there. You got the same values? Yeah. And those are the same values that are here. It's just rounded to 2 digits. You could go and go coefficients of your model. If you want to see it the same way, coefficients of your model, of model M. And there you go right there. Oh, see, we're going to put those rounds back up. Round to 7. And SciPen are digits. We need digits to 7. And SciPen. These are the global options inside of R. You usually don't want to mess with them as much as I'm messing with them. They control where scientific notation starts. And now you could take and go round the digits to 2. And there you go. That looks exactly like we see here, where we have an intercept of 1.21 and a slope of 1.26. Yeah. And then untransformed for price. If you're looking for this right here, I'm not going to do this exact step right here, but if you're looking for how to untransform, definitely check out the part earlier where I talk about, and I basically have it showing on the screen right now, how to remove a log. So if you're, once again, we only really try to untransform the Y variable. So that right there, Meath, do you think this one answers? I kind of did a lot of the work. Like I made the transform model right there. I ran it, but how does that look right there? Is that making sense? Like how to make the transform model, see if it fits, look at it, look at its coefficients, and then we could do the untransforming, which this is not the model we've made right here, but it's showing the kind of process of a transformed log 10 Y variable, because you should get that sort of model right here where you have log 10 of that, but then the untransformation process. Good stuff right there. So seeing this process right here where you have to raise it to the 10th power, and the right side of the equation, the greater should give full credit. Doesn't matter if you fix it from there. Helps a bit more. Awesome, Tyler. What else are you wondering about? I just don't understand how to write it in the form price equals some number. Make sure the grader. Let me message the grader right now as we speak and say to them, if they leave it in this format, this is fine. Let me take a screenshot. For writing or untransforming the log model, let me go to my grader. I'm going to message. So let me go find them real quick. Awesome. Okay, so let me go find. Okay, there they are. For the upcoming assignment, when they untransform the price / area question, give them full credit if they leave the 10 raised to on the other side like this. This is different data, but they can leave the right side in the exponent. This basically allow different answers as long as Y price is solved. So here we go. This is what I just messaged right here. Send it on here. Just message this to the grader so they have this information and everything should be graded along this way. There we go. Now that's not the answer, but does that make sense? It's Q2 part B, but that's what I messaged to them right there. So they should have that information and should grade accordingly. That's always good. But if you ever feel like the grading is wrong, just let me know. And then this right here. So don't worry so much about that. That's just algebra over here on the other side. We don't really care for algebra. We just care about solving for the y side of the equation. You can algebra it out if you want, but
It doesn't matter.
awesome. Any other last questions on 320? Let me know. I feel like people are doing Meath, how's it looking? Assignment pretty good. I feel like a lot of people are figuring it out. Little untransformation stuff at the end of this. You're welcome, Meath. Great work. So yeah, I feel like this is pretty like just kind of steady work. And we're going to do some more multiple regression. You're welcome, Tyler. Yeah, let me know. I feel like people are doing pretty well in this assignment right here. Officers up to a lot. Thank you so much. Just swing by anytime. Ask any questions on anything. Say, how do you make these models? How do you do this? How do you interpret this output? We like it. Let's do one more 201, then we'll end. Okay. One more 201 question. Okay. It is the 51%. Stat 201, Chapter 12 homework. And 51% of people. Did we do that one? We haven't done it today yet. It sounded familiar. 51% of people on the Chapter 12 homework. Must have done it yesterday. I thought we did it. I think it's like... It sounds very familiar. Is it the 2015 study? Is it the 2015 study? Bye, Snea. Have a great day. Thanks to the 2015 study, right? So we did the 2015 study at 1 hour, 7 minutes. No, it's not. Okay. Sorry about that. I got 43% of people. I got it right here. Okay, I see it right here. Yeah, that one's in the video at the 1 hour, 7 minute. So is it 43% of people in a certain country like to cook? So it's the percent of people like to cook. So 41% of people like to cook. 41% cooking. Okay, let's check this out right here. Here we go. 128, 13. Let's do it. 43% of people in a certain country like to cook, and 67% of people in the country like to shop, while 20% enjoy both activities. So this one right here is a bit interesting because there's overlap, so they can't easily be added. So with this question right here, let's take a look and draw it out. Really good question. Because if we have, let's draw it. I wish it didn't do that first one. 43% like to cook. So that's 43%. And then we have 67% like to shop. And then 20% have the overlap. Now, what's the first thing you notice if you add together these right here? If you add together those, what do you notice about the probabilities of cooking and shopping? What do you notice when you add them together to add together those probabilities? They're more than 100. So that should raise some alarm bells right there to be like, wait a minute, probabilities can only add up to 100% if you were to add up all the probabilities that occur. So the set of all of things that could occur can only add up to 100%. So there's a problem right here. And the problem is when you're adding these up, you're actually adding up this area twice. So the way to do this is to take the 43%, 43%, add the 67%, and then subtract off one instance of the 20%. Does that make sense? Because you're adding this up twice. It's like an overlap right there of the two things occurring. So you want to remove off one occurrence of it by subtracting it because you're basically adding up this circle and that circle, but you don't want to add this twice. So you go right here and you say 0.43 plus 0.67 minus 0.02, and that will be the probability right there is 90%. So 90% is the probability. How does that sound right there? Does that make sense? I got 0.86. And so you want to add up the two probabilities and then subtract off their intersection between them where they overlap. So this is the drawing of it right here to say the probability of this is 43%. Nice. Great job right there, Santi. You're welcome. Yeah. And then check out, we did a lot of the questions yesterday. We did them after class. You're in our section, right? Because you should have access to that because I did some during class yesterday because I know this has a lot of really hard mathy stuff. So check out the after class yesterday. Check out the office hours yesterday. Check out office hours today. There should be most of the questions. I think we've done most of them now. So yeah, there's the ones today from the quiz and the homeworks. And good stuff. I got to go put that one in there. I forgot to put the time in. And you did the, yep. There's the 2015 right there on the 107 mark right there. There it is right there. But that's got it. With that, I'm going to go eat some dinner. I might have some salad for dinner. So until then, let's put up the closing. Here we go. Closing video. Until then, wait. Bye for now, everyone. Bye.